Hey guys, all the wiring and assembling of the chassis is finally finished, and without any tubes installed, I'm checking the voltages to make sure that the proper voltages go to the proper pins of the rectifier tubes. Before installing the power tubes, you also want to make sure that the bias voltage is present on number 1 pins of both tubes. Without bias voltage, you will damage or destroy your output tubes. I'm installing both rectifier tubes but no other tubes at this point. I just want to make sure that I get DC reading on the output to confirm that the rectifiers are doing their job and that everything is wired okay in that part of the circuit. As you can see, even at very low input voltage around 90 volts, the tubes are doing their job and rectifying the high voltage. I am raising the voltage in steps so that the capacitors will also be formed without being stressed. So the rectifier circuit seems to be working as expected. Notice that after I switch the supply, we still have around 400 volts present in the amp. Since there are no tubes installed, discharging takes quite a long time. I've sped up the process here, but it took more than 5 minutes for the caps to discharge. The best thing to do is to manually discharge them before continuing. Now that we are sure that our rectifier section is doing its job and that we have bias voltage on our output tubes, we are more or less on a good way for further testing. So we can go ahead and insert the rest of the tubes. I've also plugged in the test speaker and a guitar. With a tube amp you always have to have a load on the output, otherwise you can fry your output transformer. I'm constantly monitoring the current draw, and I'm even wearing safety glasses just in case something unexpected happens. With all the tubes in place, I am again slowly bringing the amplifier on the regulated transformer with both power and standby switch in the on position. This is the first power up in front of the camera, so you'll notice that even at low voltage, after the soft start of the rectifier tubes, we've heard a loud squeal on the test speaker. I immediately switched the amp off and started troubleshooting. When you hear a loud squeal on your build, you might get scared and confused about what might have caused the problem. I've had this issue on previous builds, so I was pretty certain that the output transformer wires are hooked up the wrong way around. I've rewired the secondary leads of the output transformer going to the output jack and resoldered them, but unfortunately I forgot to record the second power up. What happened on the second power up was after I swapped the output transformer wires, I ran into another problem. No sound was coming out when I was playing the guitar, but there was a constant, very loud 50 Hz hum in the speaker. I haven't had such a problem before in my builds, so first thing I suspected was the input jacks. I thought maybe I've wired them wrong. I was all ready to start tracing the signal with the oscilloscope when I realized that there is no filament glow in the second preamp tube. When I checked the filament wiring on the second tube, I've noticed that the filament pin on the tube socket was touching the pin next to it, which was causing a major short and feeding the 50 Hz from the filament wires directly to the tube instead of my guitar signal. I've corrected that as well, and now I'm powering the amp on the camera for the third time. I've turned up the volume and no noise or hum is audible. When I started playing the guitar, the beautiful Fender clean sound could be heard on the miniature test speaker. Of course, it's very important that the guitar is out of tune for YouTube amp testing. At this point I was pretty sure that the amp works perfectly, but I still wanted to hook it up to a signal generator and oscilloscope. I fed the 1 kilohertz sine wave from a heathkit signal generator and made sure the signal is heard on the speaker. Since the signal is annoying and might damage the speaker, I've inserted a dummy load, a 10 ohm power resistor instead of the speaker. On one channel of the oscilloscope I'm checking the input from the signal generator, which is a red sine wave, and on the second channel I'm monitoring the output signal across the dummy load. You can see that the sine wave is perfectly clean and looks great even when pushed to the maximum volume and even when it starts to distort. I call this power up a pretty successful one. In the next video I will install the chassis to the cabinet and then test it with real speakers. Hope you enjoyed the video. If you like this video, give me a thumbs up, don't forget to subscribe to my channel, there are plenty more projects to come. If you would like to support me and help me make even more projects and make them more often, you can check out my Patreon page in the link in the description. Thanks for watching.